For my final recording this year, I am going to go over with you the BC exam free response solutions to the test given on May the 15th of 2018. So the first question is, people enter the line for the escalator at a rate modeled by this function right here. Now R of t is a piecewise function defined from 0 to 300, and then it is equal to 0 beyond 300. And R of t is measured in people per second, and t is measured in seconds. As people get on the escalator, they exit at a constant rate of 0.7 persons per second. So that's basically the in and out. R of t is the in, and the 0.7 is the constant out. There are 20 people in line at time t equals 0. So the first question says, how many people enter the line for the escalator during the time interval from 0 to 300? So that is basically how many people are going in, given this is the rate. So that means I'm accumulating people. So that means I'm going to integrate from 0 to 300 of R of t dt. I do not have to copy this function down because of the fact that it's already given to me. So R of t dt is 270 people. So part B, it says during the time interval from 0 to 300, there are always people in line for the escalator. How many people are in line at time 300? So what we have to do is consider several things. First of all, how many people were in line at time 0? That was 20. Then how many people got on the escalator? That was 270, the amount I just found a minute ago. And then how many people got off the escalator? And that is, they said, a value of 0.7 times how many minutes went by, because that's the integral of the 0.7 constant is 0.7 t. So you have to multiply 0.7 times 300, which gives you a value of 80 people. So that's the answer to part B. Part C says for t greater than 300, what's the first time that there are no people in line for the escalator? So what we have to look at is, okay, once we've hit the threshold of 300, when does it get down to 0? So we have 80 was how many people at 300 there were, the answer from the previous problem, minus 0.7 times t minus 300, because 300 seconds have already gone by, is equal to 0. And so you can algebraically solve that very simply, and you get t equals 414 seconds, and that tells you at what time there were no people in line. And then finally, part D, for 0 to 300, at what time t is the number of people in line a minimum? Now notice a couple things. First of all, it says a closed interval, and it's asking for a minimum, so you're going to do an absolute minimum in this case. To the nearest whole number, find the number of people in line at this time and justify, so you're going to have to do some work. So we need an equation talking about how many people are in line at any given time. So that equation I have built here is P for people, 20. The 20 is how many people that there were in line at time 0. And then this is the statement of how many people are in line at any given time x. How many people got on, R of t, how many people got off, 0.7. And then you accumulate that from 0 to x. So in order to take a minimum, an absolute minimum, just like a relative minimum, first thing you do, p prime equals 0. So you take the derivative of this, the 20 falls off, the derivative of the integral makes the integral fall off and make it r of x minus 0.7. You set that equal to 0, and you get r of x equals 0.7. And so on your calculator, you could either find where these two cross, or you can move the 0.7 over, set it equal to 0, and find the zeros. And you end up getting two values, 33.013 and 300. And those are the 2 points where it happens. So does the derivative ever fail? No. I do have endpoints 0 and 300, so I must consider those as well. So what I did is I made a table. And over here are my values on the table as to the potential critical points. Now, some of this stuff I already have, and I don't want to redo it if I don't have to. 0, 20, that was given in the original problem. 300, 270, that was what I solved in part A. And then, so the only one I actually have to plug into P to get its value is 33.013. So I come back up here, plug in that for my X. That's an integral math 9 on your calculator. And you end up getting 3.803, which is definitely the minimum. So, rounding to the nearest whole number, the minimum number of people in line was 4, which occurred at t equals 33.013 seconds. Now the work here is your justification. because I found my critical points. Specifically, I found where p prime equals 0 and went from there. All right, question number 2. Get the pages to separate. There we go. This one is the Plankton question. Researchers on a boat are investigating plankton cells in the sea. At a depth of h meters, the density of plankton cells in millions of cells per cubic meter is modeled by the function p of h for 0 to 30 on h, and modeled by f of h for h greater than 30. The continuous function f is not explicitly given. So the first question they ask is find p prime of 25, which means take the derivative, plug in a point. That is the math 8 function on your calculator. So p prime of 25, you put p of h into y1, do the math 8 function, and you should end up with p prime of 25 being negative 1.179. So interpreting the meaning of this using correct units, the density of plankton is decreasing because it's a negative derivative, it's a decreasing value. So it's decreasing at 1.179 million cells per cubic meter. And the other thing that I want to stress is the fact that if you use the word decreasing, this cannot be a negative. You can say that it's changing at a negative, but you can't say it's decreasing at a negative because that's a double negative scenario. All right, part B. Consider a vertical column of water in the sea with horizontal cross sections of constant area 3 square meters. To the nearest million, how many plankton cells are in this column of water between 0 and 30? So basically we're doing a volume with a cross section, and they just tell us that the area of the cross section is 3. So that means that we're integrating from 0 to 30 p of h times 3. So basically the area of the base times the height, and it's on its side. So when you put this in the calculator, you end up getting 1,675 million plankton cells. And that's all there is to that problem. Now, letter C, a little bit tricky. It says there is a function u such that f of h is between 0 and u of h for all h is greater than or equal to 30, and the integral from 30 to infinity of u of h is 105. The column of water in part B is k meters deep, where k is greater than or equal to 30, or is greater than 30, excuse me. Write an expression involving one or more integrals that gives the number of plankton cells in the entire column, and explain why the number of plankton cells has to be less than or equal to 2,000 million. So, first of all, we have two integrals. We have down to the depth of 30, 3 times p of h, which is what we did a minute ago. And then we have 30 to infinity of 3 times f of h, because f of h defines the density beyond 30 meters. So what you could do is you could write it this way, or you could go ahead and substitute in the value we got in part B, which was 1675. So then it's 30 to infinity of 3 times f of h dh. Now, how do we get this second part that is less than 2,000 million? Well, first of all, we know that f of h is always less than or equal to u of h. And the area under u from 30 to infinity is 105. We want to know what the area of 3 times f of h is. It has to be less than or equal to 315, which is 3 times 105. So we substitute this value in to the second equation. We know that p has to be less than or equal to 1675 plus the 315 I just found, which comes out to be 1990, which is less than 2,000 million. And so that's how you go ahead and prove that that is how it has to be less than or equal to 2,000 million. All right, part D. The boat is moving on the surface of the sea at time t is greater than or equal to 0. The position is x of t and y of t, where x prime and y prime are given. Time is measured in hours. X of t and y of t are measured in meters. Find the total distance traveled. Total distance, when you're dealing with parametrics, is the length of the curve. So the distance is going to be the integral from 0 to 1 of the square root of x prime of t squared plus y prime of t squared. That notation has already been used, so you can use it in your integral. When you do the math, you end up with 757.455. The 8 is in parentheses right here as a notation that it could be rounded up to a 6 or it could be left as a 5, so both answers are correct. You don't have to put parentheses 8, you just either have to write 0.455 or 0.456. And it is in meters per hour. It didn't specifically ask for the label, but it's not a bad idea to include it. All right, on to the no calculator part of the test. So here is the graph for number 3. The graph of a continuous function g, which is the derivative of the function f, notice I wrote f prime right there, is shown above. The function g is piecewise linear from -5 to 3, and then the g of x is equal to 2 parentheses x minus 4 squared from 3 to 6. Now what does all this mean? The fact that it's piecewise linear lets you know for sure that these are all straight lines right here, and that you can geometrically calculate the area under those curves. G of x being defined here is a parabola, so you're going to have to use that equation if you're going to do anything with the area under that curve. So part A says if f of 1 is 3, find the value of f of -5. Now here we have a scenario, like I've mentioned several times in class before, that if you are given something dealing with a derivative and you're asked questions about the antiderivative, given one point, find the other, you set it up as an integral problem. The integral from -5 to 1 of f prime, the area under the curve, which I can calculate, is equal to f of 1 minus f of -5. And now we just plug in the numbers. So the area under f prime from -5 to 1, so up to -5 to -2, that area is -9. And then the area from -2 to -1 is -1.5. It's a triangle. There is no area in there. And the area right here is 1. So that means that I have -10.5 total and a +1 equals f of 1 is 3, that was given, and I'm solving for f of -5, excuse me. So now do the math, combine all the constants, you get -12.5 equals f of -5, so f of -5 is 12.5. And there's the answer there. Oops, got ahead of myself. So now it says to find the integral from 1 to 6 of g. That means the area under the curve from 1 to 6 of g. Well, 1 to 6, kind of off the page right now, is a square and then a parabola. So we have to break it apart and find the area from 1 to 3 and then the area from 3 to 6, because one is geometric and one is not. So I set it up as two separate problems. 1 to 3 of g, because I don't know the equations for that, and then 3 to 6 of the parabola equation. So 1 to 3 of g is 4, it's 4 squares. And then the integral of this is 2/3 x minus 4 to the third, evaluated from 3 to 6. And so you plug in the 6, you get 2/3 of 8 minus 2/3 of -1. You could theoretically stop right there. That is a valid answer. But if you continue, you discover that it's 4 plus 16/3 plus 2/3, which happens to come out to be exactly 10 units. So there's the answer to part B. Now moving on to part C. Part C says from -5 to 6, on what open intervals, if any, is the graph of f both increasing and concave up? Give a reason for your answer. Okay, they're asking about f. We are given the graph of f prime, so those are the two functions that we can use in our justification. So we can say that f is increasing when f prime, or you could use g if you want to, is positive, and f is concave up when f prime or g is increasing. So we have to answer the question about f dealing with f prime. So let me bring back the graph. I need to know where this graph is positive and increasing. So I can only look over here. Right here from 0 to 1 is positive and increasing, and then from 4 to 6 it's positive and increasing. If you notice, the interval says -5 to 6, so those are the two values I have to use. So 0 to 1 and 4 to 6 is the answer to this question. And then finally, letter D, find the x-coordinate of each point of inflection on the graph of f. Give a reason for your answer. Now, once again, we have to justify f with f prime. So f prime has a point of inflection when f prime or g does what? It changes from increasing to decreasing or vice versa. So let's take a look at this graph one more time. where does this graph change from increasing to decreasing? Now, it's imperative that you don't go from increasing to constant or decreasing to constant. It doesn't work that way, or constant to decreasing. It has to go from increasing to decreasing or decreasing to increasing, and the only place that occurs is right here at x equals 4. So the answer to this question is x equals 4. Now, moving on to number 4. This was the table question. The table question talks about the height of a tree. Height of a tree at time t is given by a twice differentiable function h, where h of t is measured in meters and t is measured in years. Selected values are given in the table. Question A says use the data in the table to estimate h prime of 6, and then using correct units interpret the meaning in the context of the problem. Now we are asked to estimate a derivative, and that means AROC. So I need a difference quotient to estimate h prime of 6, which means I need to use 5 and 7. Those are the best two to estimate with. So h prime of 6 is equal to h of 7 minus h of 5 over 7 minus 5. Do the math here, etc. Now, in the past, when I've graded this question, they either need this fraction or this fraction. If you put both, great, but one or the other needs to be there, and all 4 numbers need to be there. You need to show me a difference and a quotient, subtraction and division, and then coming out with the correct answer at this point. Now, actually, that is a correct answer also without simplifying, but it's better to simplify. Now, as far as the meaning, this is a rate of change, the rate of change in the height of the tree. So the tree's height is increasing, because it's positive, at 2.5 meters per year at time 6 equals years. And it's important that the labels are there, otherwise you will not get the point for that part. Okay, letter B. Explain why there must be at least one time t from 2 to 10 such that h prime of t equals 2. Now, if you know anything about your theorems, you know that that ending looks kind of like mean value theorem. And mean value theorem is where AROC equals IROC, and the interval they gave was 2 to 10. But if you go back to the chart and look at the data and try to do an AROC to 2 and 10, you don't get an answer of 2. And so we can't use these 2 points as our points where the slope has to be 2. But if you look at 3 to 5, notice that the slope here, change in y is 4, change in x is 2. So lo and behold, from 3 to 5, the slope will be 2. And that's what I used when I did this problem. The first thing I did was show the AROC step. H of 5 minus h of 3 over 5 minus 3 ends up being 2. And so, when it comes to justifying using a theorem, it is important that you show that the hypothesis holds. Now, before I reveal what I've written below here, you need to remember that for mean value theorem, the function in question must be continuous and differentiable. Now, the directions at the beginning of the problem said it was twice differentiable. So the differentiable end of it is covered. But they said nothing about continuity, and that's where you have to say it. Since h is twice differentiable, h is also continuous. That must be there in order to get the point. And moving on, you must show that the conclusion holds as well. Since AROC from 3 to 5 is 2, and 3 to 5 is on the interval from 2 to 10 that they asked for, MVT says there must be a point C such that h prime of c equals 2. Now notice that I put MVT says in parentheses. The graders in years past have said you do not have to give the name of the theorem specifically. If you can state the theorem without giving its name, you can still get full credit. But if you accidentally call it the wrong theorem, you will not get the points for it. So you could theoretically leave those 2 words out and get full credit for this problem. So that if you're not sure if it's MVT, then don't say it. Just say there must be a point such that h prime of c equals 2. These are the hard ones to get points on to make sure you get all the bases covered. This is the one where most people fall, not stating that it's continuous as well. All right, moving on. Having to slide back and forth. So letter C says, use a trapezoidal sum with 4 subintervals indicated by the data in the table to approximate the average height of the tree. Average height. The equation is defined as height. Average height means average value. So we're not just finding the height of the tree, we're finding the average height of the tree. So that means we have to use the formula 1 over b minus a, integral from a to b of h of t dt. Now the trapezoid is estimating this. So we must include the 1 over 8, and since the intervals are not equally spaced, you have to do an individual trapezoid for each. They, on the AP exam in the past, have given a point for writing all of this out, so it's imperative that you show you know where the trapezoid numbers are coming from and you're just not pulling them out of the air. So here's the first trapezoid, second trapezoid, third and fourth, and theoretically that's the answer. You could stop right there if you wanted to, but it's a lot nicer to clean it up. So if you clean it up here, you get these values for each of the trapezoids, and then divide by 8, and that's a lot of math. I would stop right there if anything else, because you don't have a calculator at this point. That's a legitimate answer. But if you go on, you get 8.21875 is what it exactly comes out to be. So you can do either 8.218 or 8.219. And finally, letter D. It's kind of a long question. It says the height of the tree in meters. Let me move this over just a little bit. The height of the tree in meters can be modeled by the function g, given g of x equals 100x over 1 plus x, when x is the diameter of the base of the tree in meters. When the tree is 50 meters tall, the diameter is increasing at a rate of 0.03 meters per year. So x is the diameter. The diameter is increasing. That means dx dt is 0.03. Now, it says when g equals 50, because g is the height of the tree, x is the diameter. So according to this model, what is the rate of change of the height of the tree, which is dg dt, when the tree is 50 meters tall, when g equals 50? Okay. So if we need to find dg dt and dx dt, we need an equation with both g's and x's in it. And lo and behold, they gave us one. So this is the one we have to take the derivative of, and because it's a quotient, we have to use quotient rule. So we do low-d high minus high-d low over the square of what's below, making sure that you put a dx dt every time you take the derivative of an x. So the problem is, at this point, we don't plug in 50 because it says when g is 50. Well, I don't know what g, there's no place to plug a g in. So what I have to do is I have to find out when g is 50, what is x? And if you come over here, you can see you set the function equal to 50, that's this function up here, do the math, and you end up with x equals 1. So the 1 is the value I plug into my dg dt. So I'm plugging in 1, get 2, 100, 0.03, 1, 100, 0.03 over 2 squared. And then when you clean it all up, you get 6 minus 3 over 4, which is 3/4 of a meter per year. So that is the rate of change of the height of the tree. Okay? Moving on to number 5, I believe is next. Yes. The polar graph. So you can see it, there it is. This is the first time that I know of in a while that they put a polar graph without a calculator, but that's okay. It's pretty straightforward. The graphs of the polar curves, r equals 4 and r equals 3 plus 2 cosine theta, are shown in the figure above. They intersect at pi over 3 and pi over 3. Now, they were pretty nice about this. R equals 4 is a circle. So that has to be the circle, the one that's exactly a circle. And that means the other one is the curve, the limacon. Okay? Pi over 3, 5 pi over 3, pretty obvious where they cross, right there and right there. Okay? Let R be the shaded region that is inside the graph of the circle and outside the graph of the limacon. So even here, they're being even more specific about which graph is which. Write an expression involving an integral to find that area. Now, if you look at it in the manner that I mentioned earlier, dealing with a sprinkler, if you were going to do the sprinkler for the circle, it would start over here, work its way around. But actually, we need to start here to cover all of this area right here as far as the circle is concerned. But I don't want all of the circle. I want the limacon cut out. So it's going to be the circle minus the limacon. But remember that polar has a different formula. It's 1/2 r squared d theta. So r equals 1/2 the integral from pi over 3 to 5 pi over 3, outer, which is the 4 squared, minus the inner squared d theta. So it's like you're doing the area of the circle and then minus the area of the limacon. So that's all you had to do for that one since you don't have a calculator. Now, letter B was a little bit more involved. Find the slope of the line tangent to the graph of r equals 3 plus 2 cosine theta at theta equals pi over 2. Now, slope of a tangent line is dy dx, and my equation is all in r's and thetas. So what I have to do is change my equation from r's and thetas to x's and y's. So what we use are the formulas that you learned in pre-cal. First of all, x equals r cosine theta. Now before I go any farther, let me show you over here where I'm headed. dy dx is equal to dy d theta over dx d theta. So I'm trying to create these two equations, dy d theta and dx d theta, at pi over 2 so that I can plug them in. So here's my first step. X equals r cosine of theta. That's a given quantity, a given formula from pre-cal. Now r is equal to this. So I substitute r in for that times cosine of theta, and then I'm going to do product rule to find the derivative of this. Dx d theta equals 3 plus 2 cosine theta times negative sine, and so on. Clean it up, and I get to here. And now I want to know what it is at pi over 2. So go ahead and plug pi over 2 in now, and I get the value of negative 3, which is the denominator of my slope. Okay, I do the exact same thing for y. Y equals r sine theta. Substitute in what r equals for the equation of the limacon. Use the product rule to find the derivative. You get your answer here. Plug in pi over 2 and you get negative 2 for an answer here, which goes in the numerator. So my final answer is a positive 2/3 for the slope. So it took a little more writing to do this one, a little more number crunching as far as that's concerned. Part C. A particle moves along a portion of this curve from 0 to pi over 2. The particle moves in such a way that the distance between the particle and the origin increases at a constant rate of 3 units per second. That looks very intimidating. However, if you just think, the distance between the particle and the origin is known as r. It's just the radius. So dr dt is 3. The question says, find the rate at which the angle theta changes with respect to time, which is d theta dt, at the instant when the position of the particle corresponds to pi over 3. Indicate units of measure. That means there's point values tied to the label. Don't forget that. So, dr dt d theta dt. I need an equation relating those two, and I have one. It's right here. So I recopied my formula, and I take the derivative of both sides in terms of t. dr dt equals negative 2 sine theta d theta dt. Start plugging stuff in. 3 is dr dt, pi over 3 is theta. Do the math. Solving for d theta dt, you get 3 over negative radical 3 is d theta dt. Now what you could do is just squeeze a label in there, but I went ahead and wrote a sentence. The angle theta changes at negative 3 over radical 3 radians per second. Because it's an angle, it's got to be radians, and the unit of time that's given is seconds, so it's radians per second when theta equals pi over 3. All right. Finally, if I get the pages to separate, number 6, the series question. The Maclaurin series for ln of 1 plus x is given by this formula. They gave it to us. Thank you very much. On its interval of convergence, the series converges to ln of 1 plus x. Let f be the function defined as x times the ln of 1 plus x over 3. Now, on the work on the first one, I skipped quite a bit of work, so hopefully you can follow along with what I've done. Write the first 4 non-zero terms and the general term of the Maclaurin series for f. So what I need to do is notice that to change this to this, the x turned into an x over 3. So that means I'm going to have a 3 on the bottom of each of these with the same power as the x is. And then I have to multiply by another x, which means the power of each of these is going to be 1 higher than it was before. So the first 4 non-zero terms right here, this x becomes x squared over 3 because the x changes to x over 3, and then I multiply by another x. This x squared changes to x squared over 3 squared, but then it gets another x, so it's x cubed. This x changes to x cubed over 3 cubed, but it gets another x, so it's x to the 4th, and so on. And then you can see the pattern. X to the 5th, 3 to the 4th, and 4. And then when you get to the general term, it's an alternator, so it's negative 1 to the n plus 1, x to the n plus 1, because it's 1 higher than it was before, over 3 to the n times n. So there is the first 4 terms in the general term. Okay, now we have to do the interval of convergence and show the work that leads to your answer. Now remember the steps for interval of convergence. Always use ratio test, set it less than 1, find the interval, test the endpoints. Make sure you do it in that order. So we take our general term, make everything 1 power higher, n plus 1. So x becomes n plus 2, 3 becomes n plus 1, this becomes n plus 1. You can drop the alternator because it's in absolute value. Then you put the original on the bottom. When you flip it up and clean it up, you get n over 3, n plus 1 times the x is less than 1. Remember you set it less than 1 to make it converge. The limit of this, n over 3, n plus 3, is 1/3. So that becomes 1/3 of x is less than 1, negative 1 less than 1/3 x, 1 less than 1. So our interval is now negative 3 to 3. So I know now that it's going to be between negative 3 and 3, but I have to test my endpoints. I'm purposely keeping my hand here because I don't want you to see the final answer just yet. So, negative 3, when you plug it in, you get negative 1 to the n plus 1, negative 3 to the n plus 1, 3 to the n times n. And so, these two multiply together because their exponents are the same. So that's positive 3 to the n plus 1 over 3 to the n times n. This cancels this, leaving a single 3 on top over n. That diverges because it's harmonic. So I immediately know that's going to be a divergent. Positive 3, on the other hand, is a little bit different. The negative 1 to the n plus 1, 3 to the n plus 1, I could combine them, but I don't want to because I want the 3's to cancel. So I leave this alone. That's going to be a single 3 over n. So I have now an alternating harmonic series, which with multiple times of doing these problems we discovered converges. This is a conditional convergence. It's an alternating harmonic series. So that means negative 3 gets the parentheses, positive 3 gets the bracket as far as the interval of convergence is concerned, because of the way that they converge and diverge. Okay, finally, last question says, let P4 of x, let me move it down just a little bit more. Let P4 of x be the 4th degree Taylor polynomial for f around 0. Use the alternating series error bound to find an upper bound for this. Now the difference between these two, absolute value, is the error. So we're trying to find what the error is. So if you go back to this one right here, it says 4th degree. So that means I'm basically stopping my formula right there. Use the alternating series to find the error. Now remember that with alternating, the error is just the next term. So there's my error term right there. The x to the 5th over 3 to the 4th times 4. So when I come over here, I put it in absolute value, that its error is absolute value. Because 2 is substituted in, that means 2 becomes x. 2 to the 5th, 3 to the 4th times 4, that is a legitimate answer. But if you want to simplify it very quickly without doing a whole lot of math without a calculator, 4 is 2 squared. So 2 to the 5th over 2 squared becomes 2 to the 3rd over 3 to the 4th, which both of those are easy to compute, 8 over 81. And that is the final question on the BC test. Hope you did well, and I hope this was helpful in understanding how these problems are done.